right, so let's look at problem number 4. Is talking about a canoe and a raft making a head-on collision, and it actually tells you that the raft bounces off of the canoe. So this is the situation. You have a raft at 4 kilograms. It's moving to the right at 6 meters per second. You have a canoe, not a banana, a canoe that's moving to the left at 16 has a mass of 16 kilograms. It's moving to the left at 12 meters per second. I've attached the negative to show that it is moving to the left. So they're moving towards each other, and then this is before the collision, this is after the collision. So they've collided, and now they're moving in opposite directions, probably. We'll see what happens with this. This raft is actually moving to the left, so they collided. The raft bounces off. We want to know what happens with it. Does it continue to move in this direction, or does it bounce off and go in the opposite direction? It's moving off at a velocity of 22.7 meters per second. I've added the negative to show that that is going to the left. So let's solve for the momentum before and then put that equal to the momentum afterwards. So I'm going to take the 4, multiply it times the 6, that's a positive 6 meters per second. So that gives me 24, that's a positive 24 kilogram meters per second. Now I want to solve for the momentum of this one, which is the 16 kilograms. And then I have a negative 12 as the velocity. And again, that's just telling me that I have motion to the left. So 16 times negative 12 gives me minus 192 kilogram meters per second. So that is a lot of momentum moving to the left. It's negative, so that's a lot of momentum moving to the left. And then there's a small amount of momentum that's moving to the right. So actually, if I add these together, I'm going to end up with negative 168 kilogram meters per second. So probably what looks like is going to happen is that they're going to collide, and the banana boat, the canoe, is going to continue to move to the left, and I bet that that's what it does. So let's take a look at it. Now we look at afterwards, all of this has to be equal to what we solved for earlier, conservation of momentum. So I can go ahead and say 4 times the 22.7, that's a negative 22.7. So 4 times negative 22.7 gives me negative 90.8 kilogram meters per second. Now I have to add it to this, that's 16 times, we don't know some velocity, so 16v. So I know that this has to be equal to this, what we saw for earlier. So I can go ahead and write an equation that shows that. Negative 168 kilogram meters per second is equal to negative 90.8 kilogram meters per second plus 16 times some velocity. So the first step into this is to add 90.8 kilogram meters per second. Gets rid of that. So I'm going to add 90.8 kilogram meters per second. So negative 168 plus 90.8 gives you negative 77.2 kilogram meters per second, and that's equal to 16v. 16 times some velocity. Divided by 16 on both sides, that's positive, right? Well, it's a positive, so because it's mass is what we're dealing with. So negative 77.2 divided by 16 gives you minus 4.825 meters per second. So that negative 4.825 meters per second is the velocity. The negative tells me that it's going to be moving, just like we predicted, it's going to be moving to the left at 4.8 meters per second. So before, they're going in opposite directions, they collide, the canoe bounces back and moves to the left, and the canoe continues to move left. How fast is it moving? It's moving at 4.8 meters per second. Let's take a look at number 5. You have 2 railroad carts. One is moving at 7 meters per second to the north, sticks to another one that's moving in the same direction at 1.5 meters per second. So you have two carts, both moving north, one at 7 meters per second, one at 1.5 meters per second. They both have a mass of 15,000 kilograms. So this one, they collide, and now the mass is the combination of those two, and we want to know how fast is it moving. We predict that it'll probably be moving in a northern direction, towards the north. So we want to figure out what is the momentum beforehand. So I can take 7 times 15,000 and then figure out what that is. So 15,000 times 7 is 105,000. Then I'm going to do 1.5, which is the velocity times the mass. Multiply those two, and I get 22,500. So if I add these two together, I get 127,500 kilogram meters per second. That is the total amount of momentum, and we know that it's positive because that's positive and that's positive. So our total momentum is plus 127,500 kilograms. So this has to be equal to this. So I can say that plus 127,500 kilogram meters per second is equal to the mass, which is 30,000, combination of the two, times some velocity. That's what we're looking for. We don't know what that velocity is of the cart. So this is very easy. All I have to do is divide by the 30,000 on this side, 30,000 kilograms. So 127,500 divided by 30,000 gives me 4.25 kilograms, cancels out. I'm left with meters per second is equal to velocity. And that's a positive. So positive means it will be moving in the positive direction. So just as we predicted, we thought it was going to be moving in an upward direction to the north, to the positive direction. So before, we have two separate, one's moving at 7, one's moving at 1.5. They collide with each other, and afterwards they're moving with a velocity of 4.25 meters per second to the north. It continues in this upward direction. So for positive, 4.25 would be the velocity of the train cars. And I think you have enough. You should be able to figure out 6, 7, and 8 on your own. 6, 7, and 8.